All right, so we're looking at section 11.2 on the hyperbola. So remember, like if we have our conic here and we have the plane or our cone, right? You can see like if the plane's cutting the cone, like where it's going to be like straight up and down. You can see what kind of shape we would get is called the hyperbola, which is kind of like a double parabola, if you will, right? Something like that. So the definition of a hyperbola is the set of all points x, y in a plane such that the difference in the distances between x, y and two fixed points called the foci is a positive constant, right? So notice, kind of the big difference here between, between the last section is that, the constants were the sum of the the sum of the differences was a constant, where in this case it's the difference, right? So that was with the ellipse, right? So remember in the ellipse, the sum of the distance was constant. In this case, the difference is is constant, right? All right, so what I have here is just a diagram out of the textbook, and I want to label some parts for you in this. So some of them are already labeled, like the vertices and the foci. They're already labeled, and the generic point x1 and the distances, those are already labeled. But some other things that I want to add to this is that this point here, this is of course called the center, and just like in the last section, we're only going to look at hyperbolas that are centered at the origin. And then something else that I want you to note is that this kind of red line here, that is called the transverse axis. And then the last thing I want you to note, just some terminology, is that these two things, these are referred to as branches. Right, so we have two branches here with the hyperbola. Right. So then on pages 969 and 970, you could look over those if you're interested about how to derive the equation for a hyperbola. So for time's sake, I won't do that. But there are some things that we want to note in this chart. So notice here, it says the standard form of equation of a hyperbola centered at the origin are as follows. Assume that A is greater than 0 and B is greater than 0, right? So, similar to before, A is going to be positive, B is positive, and C is going to be positive, right? But if you remember before, A was always greater than B, right? But that's not necessarily going to be the case here. So one thing you want to notice is if you look at where the A is, it's always underneath the variable that has a positive coefficient, right? So A squared is always below the positive coefficient. All right, maybe word it like this. It's always below the variable term with a positive coefficient. Right, so that sounds better. Right, so that's what we're looking for there. So notice also, we have kind of two different versions here of hyperbola. So like if we just focus in on the graphs here, we have one that where the branches are like opening outward, like towards the X, like left and right. And then the other option is where the branches are like opening up and down, right? So that's going to be a difference of where the transverse axis is, right? So remember, this part here is the transverse axis.
So notice here we label them based on if the transverse axis is on the x-axis or is it on the y-axis, right? Right. So then some other things that you want to note, like why we're focusing on the graph, is notice we have like this rectangle here and this dashed line. So that is called the reference rectangle, right? And the reason why we draw this reference rectangle is we have these other dashed lines here that are drawn like diagonals through this reference rectangle, and those are referred to as the asymptotes, right? So the equations for those are here. So those are the asymptotes, and what those are useful for is to help us draw, if we were to draw this by hand, to be able to draw those, right? So that's where those come in, right? So then some other things in the table here. So of course the center's at 0, 0 the entire time, the origin, but then we also have the foci and the vertices, equations for those, and equations for asymptotes, right? Another thing I want to bring your attention to when we're looking at the foci is the equation to calculate like how A, B, and C are related is different in this case, right? So it's C squared equals A squared plus B squared, right? So you just want to pay attention to that, right? But also another similarity is notice that these equations in standard form still are equal to 1, right? So that's going to be important still, right? So then we're not actually going to focus real heavily on graphing hyperbolas, but if you're interested, these are kind of the steps to walk through to do that. So there's no graphing of hyperbolas on the homework, and I'm going to just show you how we can just type that in at Desmos and come up with a graph pretty easy. So I'll walk you through how to do that in the coming examples. Right. So example 1, we have a hyperbola equation x squared over 16 minus y squared over 25. Right. So we want to identify the center, the vertices, the foci, and also write the equation of the asymptotes. Right. And then I'm going to do maybe another part. I'm actually going to graph the equation in Desmos. Right. All right, so the first thing that I would want to do is kind of try to figure out my A, B, and C values, right? Because I'm going to need all of those in order to find the center, the vertices, foci, and so forth, right? Those are kind of like the characteristics of the equation, right? So first thing we want to look for is which variable has a positive coefficient. That's x squared. So that tells me, 1, that my graph is going to look something like this, right? Where we're opening left and right along the x-axis. And also, that tells me that this value is a squared, right? So that means that a would be 4, right? Just the square root of 16. And then so what's left is this value would mean that b squared is equal to 25. So that tells me that b is 5, right? So the relationship between a, b, and c is c squared equals a squared plus b squared. So this gives me c squared equals... it's 16 plus 25, which equals 41. So then c would equal the square root of 41, right? And that doesn't simplify at all, right? So we have a squared in a, b squared in b, and c squared equals 41, and c equals radical 41, right? So we're going to need those parts throughout. So part A, pretty simple, right? Because we're only looking at where the center is at the origin. So we can just write down the origin. The vertices, right, from that table, we're looking in the first column. We have a comma 0 and negative a comma 0 as what those points would be. So this would be 4 comma 0 and negative 4 comma 0, right? So not too crazy. Part C is we're identifying the foci. So with the foci, those are going to be in the form c comma 0 and negative c comma 0. So c is radical 41, so that would be radical 41 comma 0 and negative radical 41 comma 0. And then lastly, part D, we want to find the asymptotes. So those are at y equals b over a times x, and y equals negative b over a times x. Right, so b is 5, so this would be 5 fourths, a is 4, x, and then this would be negative 5 fourths x. Right, so if you want to write that a little cleaner, the asymptotes would be 5 fourths x and y equals negative 5 fourths x. Right, so then part E, we want to graph this on Desmos. So let me put my keyboard back on and we'll get that up. All right, so if you just go to desmos.com, you can hit start graphing, and then we can just type in the equation into here. Let's see. So I'm just going to put x squared divided by 16 minus y squared divided by 25 equals 1. Right, so you can see that we get that equation. Of course, right here at this point, right, so that point 0, 0 is the center, so we can graph the vertices as well. So that's what a 4 comma 0 comma negative 4 comma 0. So there's the vertices. The foci is the square root of 41 comma 0 and negative square root of 41 comma 0. Right, so there we can see the foci. And then lastly, the asymptotes is y equals 5 fourths x and y equals negative 5 fourths x. Right, so we can see all of that labeled in. All right. All right, so I'd like to go to the second one. So this one's slightly different. Notice that the equation is not in that standard form. We want that right side to be 1, and currently it's 784. So we're going to have to do some manipulation here to get it in that standard form first, but it's not too crazy hard. Right, we need this to be 1. So part A, we have 49 y squared minus 16x squared equals 784. So I can divide both sides by 784. So this gives me 49y squared over 784 minus 16x squared over 784 equals 1. So 49 divided by 78, that reduces down to be 1/16, right? So we'd have y squared over 16. And then 16 divided by 784, that reduces down to be 1/49. So this would be x squared over 49 equals 1. So then now I have it in that standard form, right? And what you want to pay attention to is this term that's positive, right? So since that's positive, and it's the y squared that's positive, right? That tells me that my graph is going to open up and down, right? We're going to have a situation like this, and that also tells me that that denominator is going to be a squared, right? So remember, a squared is not always going to be the biggest number in this case, right? It's always the value underneath the variable that has the positive coefficient. So then, since we know a squared and b squared, I can find a and b pretty easy, right? So the square root of 16 is 4, the square root of 49 is 7, so a is 4, b is 7, and then we know that c squared is equal to a squared plus b squared, which would be 16 plus 49, which turns out to be 65, right? So c squared equals 65, and c would be the square root of 65 then, and that doesn't simplify, right? So we're going to need these values and these values, right? So we found those kind of like the characteristics. So then part A, we're asked to find the center again, right? But of course, that's just the origin. Part B, we want to know the vertices, right? And then from that, original table we looked at, that's always in the form a comma 0 and 0 comma negative a, right? 0 comma a and 0 negative a. So we just plug in my value for a, and I get 0 comma 4 and 0 negative 4, right, for those vertices. All right, so I'm going to come over here. Let me change colors. So next, we want to find the vertices. So the vertices, or wait, I already found the vertices. We need the foci. So this is part C, foci. So the foci are in the form 0 comma c and 0 negative c, right? So my value for c was radical 65, so that would be 0 comma radical 65 comma 0 comma negative radical 65, right? So there's the foci. Part D is to write the equations for the asymptotes. So in this one, it would be a divided by bx, and y equals negative a divided by bx. Right, so a is 4, b is 7, so this would be y equals 4/7 x, and y equals negative 4/7 x. Right? And then if you'd like, you could go ahead and graph this equation in Desmos just like we did previously, and you could graph the each individual part. You could see how that looks visually, right? So I'll let you do that. So part E, we'll just say graph on Desmos, and this will be on your own. All right, so you can graph and see what that looks like. All right. All right, so then example 3, we were asked to find the asymptotes of the hyperbola given by the following equation. So, if we look at the table to get the asymptotes, what I need to find is what A and B are, right? So I need to find A and B so I can answer the question, right? So notice this is not in standard form. So that's the first thing I would start with. All right, so we actually want to get this number over here, right? So I would subtract 15 from both sides, and we get 3x squared minus 5y squared equals negative 15. And then remember, we want this to be 1, right? So what I can do is divide both sides by negative 15, which gives me 3x squared over negative 15 plus negative 5y squared over negative 15 equals 1. So then we need to simplify these. So 3x squared divided by negative 15, that would simplify to be what? Negative x squared over 5, right? And then we'd have plus, this would be y squared over 3, right, equals 1. And notice, by convention, usually we write the positive one first, right? So if we just swap those, we would get y squared over 3 minus x squared over 5 equals 1. So now that, that's going to be in standard form. So, just real quickly, notice that y squared is my positive, my variable with a positive coefficient. So that tells me my hyperbola is going to be opening up and down. That also tells me that a squared is 3. And so that leaves b squared to be equal to 5, right? So that tells me that a is radical 3 and b is radical 5, right? And since I know that they're opening up and downward, I know that the equation for the asymptotes, which is what we're after, is equal to y equals a divided by b times x, and y equals negative a divided by b times x. So if I fill these values in, right, we would have, so a squared of 3 and b squared of 5, x, and then this would be radical 3 divided by radical 5x, right? And this would be equal to, radical 3 divided by radical 5 times radical 5 over radical 5 times x, right? So I'm trying to rationalize the denominator. So that gives me radical 15 over 5 times x, right? And same thing here. That should be negative. We would have negative radical 3 over radical 5 times radical 5 over radical 5. To rationalize the denominator, that gives me negative radical 15 over 5 times x. Right? So then my asymptotes are y equals radical 15 over 5 times x, and y equals negative radical 15 over 5x, right? Or in other words, y equals plus minus radical 15 over 5x, right? So those are the two asymptotes. Right. All right, so then the next one, example 4, we're asked to find the foci for the hyperbola that passes through the point 4 radical 5 comma 14 and has vertices at plus minus 4 comma 0, right? So thinking through this a little bit, these vertices at plus minus 4 comma 0, right? I can kind of graph those. Right, we'll say that this is 4 0 and this is minus 4 0. So remember, the vertices is, basically like the vertex of a parabola, right? If you have a parabola, this bottom part's a vertex. So since these vertices are here on the x-axis, that tells me that my graph is going to be opening, left and right. Right, so in other words, my transverse axis is going to be on the x-axis, right? So it's like that first scenario that we looked at in that table, right? So that's some information that tells me. Also, then now that we know the shape, this coordinate is supposed to be a comma 0, and this coordinate's negative a comma 0, right? So that tells me, since that matches with the ordered pair 4 comma 0, that a must be equal to 4. Right? So we're trying to find the foci. So the foci, would be in the form c comma 0 and negative c comma 0. So ultimately, I want to find c, right? But in order to find c, I'm going to need to know what the b value is, right, to be able to find that. So what we can do is, since I know it opens left and right, I know the general form of the equation is going to be, x squared over a squared minus y squared over b squared equals 1. So, this is 1 point on the graph. So what I can do is plug that point in for x and y, and then I know what a is, so I can plug that in, and then so the only thing missing would be the value for b, right? So what we would have is 4 radical 5 quantity squared over, and then 4 squared minus, and then y is 14 squared over b squared, which equals 1. Right, so we're after trying to find b, so then we can find c. Right, so we want to solve for b. So 4 radical 5 squared would be 4 squared and then radical 5 squared, right, using exponent rules. 4 squared is 16. We'd have minus, so 14 squared is 196 over b squared equals 1. So, this 4 squared here, this is actually 16. So these end up canceling out, right? And then radical 5 squared is just 5. So what I end up with is 5 minus 196 over b squared equals 1. And then I could subtract 5 from both sides and get negative 196 over b squared equals negative 4. And then I could multiply both sides times b squared to get negative 196 equals negative 4b squared. And then I could divide both sides by negative 4. So that gives me that b squared equals, negative 196 divided by negative 4 is 49. So that gives me that b then would be equal to 7, right? So we were after that, after those values. So then now I can finally solve for c like I was after. So remember that a squared plus b squared is equal to c squared, right? So c squared would be equal to, so a squared would be 16 squared, right? Or wait, no, 4 squared. It would be 16. A squared was 16, right, from here. And then b squared was 49. So c squared must be equal to 16 plus 49, which 16 plus 49 is 65. So that tells me that c is radical 65, right? And that doesn't simplify. So we were after that value. So now I can finally just plug that in up here. So the foci would be radical 65 comma 0 and negative radical 65 comma 0. Right? So that answers that question. Right? So, with these, you want to really, think about, does this open, to left and right or up and down? Think about what you're given, what you need to find, and how to get there, right, is something important with this section. Really this chapter on conics, right? That's what you have to really be able to think about. So then objective 2 is where we're centered at, some other point that's not the origin. So we're like I said, we're omitting that from this course, and that's that's what Ohio State's math department has decided to not worry about that. So then moving on to the next objective, which is objective 3. So we want to determine the eccentricity of a hyperbola, right? So for the hyperbola defined by, so if we have x minus h quantity squared divided by a squared minus y minus k divided by b squared equals 1, or the opposite, the other equation there, the eccentricity is given by the formula E equals c divided by a, right, where a and c are both positive, and c squared equals a squared plus b squared, right? So what this is going to be true is just a note here that the eccentricity of a hyperbola is a number greater than 1, so e is always bigger than 1, right? And that's the equation to solve for the eccentricity, right, like we looked at before with the ellipse. And just like I noted before with the ellipse, since we're letting hk be 0, 0, right, the origin, so you can kind of just get rid of that, the minus k and the minus h, right, because we're not looking at anything different than that, right? So something that's going to be important to note about eccentricity is that the greater, the eccentricity, the wider that the branches open. Right? So if we look at example 5, first of all, we want to determine the eccentricity of each hyperbola. And then part B, based on the eccentricity, we want to match the equation with its graph. The scaling is the same for both graphs, right? So we have two equations, we have two graphs, and with this fact that I just wrote down, that the greater the eccentricity, that's going to cause the branches to be wider, right? That this one, this one is going to have a greater eccentricity than this one, right? So the eccentricity of graph A is going to be greater than the eccentricity of graph B, right? So, working with both equations, we just want to find what those values are so we can figure out the graphs. So for equation 1, we have x squared minus y squared. So x squared over 144 minus y squared over 81 equals 1. So, this value, 144, is going to be a squared. And b squared is going to be 81. So that tells me a is 12 and b is 9. Right? And then we need to find c as well, right? Because the eccentricity, right, is equal to c divided by a, right? So c squared is equal to a squared plus b squared, which we would have c squared equals 12 plus, not 12. We would have 144 plus 81, right? A squared plus b squared, which gives me 225. And then if I take the square root of 225, we get 15, right? So c is 15. So the eccentricity for equation 1 would be 15 divided by 12, which reduces down to be 5/4, right? And then next, looking at equation 2, we would have, we have x squared over 81 minus y squared over 144 equals 1. So a squared is 81 and b squared is 144. So a is 9 in this case and b is 12 in this case, right? So basically the a squared and b squared values just switched, right? But actually for the c value, it's going to be this same work, right? The only difference is we would have c squared equals, 81 plus 144, but that's still equal to 225, right? So thus c would still be 15. So the eccentricity would be c divided by a, which would be 15 divided by 9, which that reduces down. I can divide top and bottom by 3 to get 5/3, right? And this guy, the equation 2 eccentricity is greater than the eccentricity for equation 1, right? So, what that tells me is that this one is equation number 2, and this one is equation number 1. Right. In other words, equation 1 goes with graph B, and equation 2 goes with graph A. Right. All right, so then the last objective is looking at some applications. This is just, pulled directly from the textbook. They, give you, some applications of hyperbolas arise in many fields. For example, astronomers know that some comets, such as Halley's Comet, follows an elliptical path around the sun. Other comets have a hyperbolic orbit because they are not captured by the sun's gravity, right? So that's just telling us, an application, is in astronomy that sometimes a comet, right, can have an orbit that's hyperbolic, right? So then another application is something pre-GPS, right? So hyperbolas also provide the mathematical basis for the LORAN, which is the long-range navigation. So this was a technique used for navigation before we had GPS, global positioning systems. So a ship using LORAN measures the difference in time between synchronized radio signals from two different transmitters. Using the relationship distance equals rate times time, d equals rt, the difference in distances between the ship and the two transmitters, d1 minus d2, can be computed. Thus, the position of the ship is located at the hyperbolic path with the two transmitters at the foci. Right? So that's one application of that. So then I have one example here. Example 6, and then we'll call it a day. So we have two. Example 6 is we have two radio transmitters that are 1,000 miles apart at points A and B along a coastline. We want to use Lauren on the ship. The time difference between the radio signals is 4 milliseconds. If radio signals travel 186 miles per millisecond, find an equation of the hyperbola with foci at AB on which the ship is located. Right, and we have a diagram listed here to help us. Right, so essentially notice that A and B they have negative 500 and 500, 0. Remember, those are the foci. Right, and since those are the foci, what we can do is if we treat this line is like the x-axis, then somewhere in the center here is going to be the y-axis, right, where that points to the origin, right? So that tells me that this, for point A, that's going to be in the form c comma 0, or that would be actually negative c comma 0, and point B would be in the form c comma 0, right? So what that tells me is that c must be equal to 500, right? So that's one thing to note. So we're trying to find the equation. So to find the equation, and something else to note is that my equation, if those are the foci, we're going to have some parabola that's opening left and right towards the foci. Right, so that's going to be in the form x squared over a squared minus y squared over b squared equals 1. Right, so what I need to know what A is, and I need to know what B is. Right, we need to try to figure that out. So some things that we can know is that D1 minus D2, that's going to be equal to the rate times the time, right? That was provided in that page in the application. So that would be 186 miles per milliseconds times 4 milliseconds, which this gives me 744 miles, right? So then from page 969, we actually know a relationship between D1 and D2. D1 minus D2 is equal to 2 times A, right? So what I can do is plug this in to D1 minus D2, and then I have an equation then with one unknown. I can solve for A, the value for A. And then once I know A, since I already know C, I can use my relationship between A, B, and C to find the missing value B that we need, right? So we would have 744, right, equals 2A. I can divide both sides by 2, and this gives me that A equals 372. Right, so I have A, I have C, now I need to figure out B. So what we know is that A squared plus B squared equals C squared. So we would have 372 squared plus B squared equals 500 squared. So B squared would be equal to 500 squared minus 372 squared. So this gives me 111,616. Right, so then I just need to fill in the values into my equation. So we would have x squared over a squared, which would be 372 squared. So 372 squared is equal to 138,384. Right, so I can fill that value in here. Then we'd have minus y squared over b squared, which is 111,616, and that's equal to 1.
right? So there's the equation for that hyperbola, right? All right, so that's all I have for this section. Make sure you let me know if you have any questions. Thanks.